This is ultrasonic sensor, which is used to measure the distance of an obstacle ahead. And in this video, we're gonna be learning how to use this ultrasonic sensor with Arduino. And let's go. So, if I tell you the basic structure of this ultrasonic sensor, here there are 4 pins, and we provide a voltage of 5 volt to this ultrasonic sensor. And this ultrasonic sensor sends ultrasonic rays and then calculates the time difference between the rays sent and rays received by this ultrasonic sensor. Along with this ultrasonic sensor, we're gonna be using this Arduino Uno to power this ultrasonic sensor and calculate the distance of an obstacle ahead of it. And to power and send port to this Arduino, we're gonna be using this pin. Also, we're gonna be using this 800 pins breadboard. You can use any type of breadboard here, but we will be using this one. So first of all, connect this ultrasonic sensor with this breadboard. We're gonna be using this jumper wire. So let's connect this ultrasonic sensor to this breadboard, and we will connect it here just like that. Our pins are separated from each other and well connected. Then we will be using for this voltage red wire for this voltage, and for this ground pin we will be using this black wire just like that. And we're gonna be using these two pins for trigger and echo pins. In this way, all 4 pins are connected to this ultrasonic sensor. Now let's connect the red pin to here, the 5 volt pin of this Arduino, and the ground pin to the ground pin of this Arduino. So let's connect it. Just like that. And for these two pins, we're gonna be using digital pins of this Arduino. Here are the digital pins, and we're gonna be using digital pin 8 and digital pin 9 for these two wires. Green pins, which is the echo pin, will be connected to the digital pin 9, while the yellow pin, which is the trig pin, will be connected to the digital pin 8. And in this way, the two pins will be connected to Arduino. Now it's time to connect this Arduino with this USB Type-C cable so that we can upload our code to this Arduino. So here you can see that Arduino is fully connected and it's time to code. Let's go. So first of all, we're gonna be setting up the variable for trigger pin and echo pin. Uh, so for trigger pin it's the pin 9, while for the echo pin it's the pin 8. As we have made these connections in our Arduino Ultra solutions, and then we're gonna be using serial.begin as we have to print the distance of an obstacle ahead, while we're gonna also be setting the pin mode for the trigger and echo pin. For trigger pin it will be output, while for the echo pin it gonna be input. Then inside the while loop, first of all we're gonna be writing digital write low for the trigger pin. Then we're gonna add a delay for microseconds of 2 microseconds. Then again we're gonna be writing digital write high this time for the trigger pin. Sorry, for the trigger pin. Then again a delay of 10 microseconds here. Then again we will be writing digital write low for the trigger pin. In this way our ultrasonic rays gonna be sending and received by the echo pin. Then we're gonna be writing the duration for this sending and receiving by the echo pin. Then we're gonna be changing this duration into distance. As we know, the speed of this ultrasonic sensor, which is equal to the speed of sound 0.0343, and divide it by 2 as it is as we need the distance only from the obstacle. Then we're gonna be printing 0 dot begin distance and write the distance ahead of an obstacle in centimeters, just like that. And let's verify our code here. And the code is verified and it's time to upload our code. And the code is successfully uploaded to our Arduino. And now it's time to test. And now we can clearly see that whenever I place my hand in front of this ultrasonic sensor, the distance value decreases while I took it away from this ultrasonic sensor. The distance value increases. It means the ultrasonic sensor is successfully working here in this case.